In this video, I'm going to be showing you how to flash a Silicon Image SIL3112 based SATA controller card for use on a PowerPC Macintosh. Now, as you can see here, this particular card that I'm going to be using in this video is actually quite unique. And that is because, in addition to the SIL3112 controller here, it also has two other controllers for both FireWire or i1394, this VIA controller right here, as well as an NEC USB 2.0 controller. And the reason that is significant is because both of these controllers, in addition to the SIL3112 after being flashed, are compatible with PowerPC-based Macintoshes and, of course, with macOS. Now, in addition to those two controllers, this particular card also has this PLX chip here, and this is a PCI to PCI bridge. And this serves no purpose other than to only take up one device on the PCI bus and then split it off into three individual devices, as you can see right here. Now, in theory, this chip really isn't necessary because all devices on PCI are connected in parallel, basically. But I guess what the point of this is so there will only be one device taken up on the PCI bus rather than three if they were to just pass them all through and tie them all together. And this particular chip is a PCI 6152 made by PLX, as you can see there. Now, this particular card was actually sent in to me by fellow YouTuber and fellow vintage Macintosh enthusiast, Action Retro, here on YouTube. So go ahead and check out his channel if you want to see more about this card once I return it to him after flashing it. So with that out of the way, the first thing you need in order to flash a card like this, and this applies to any SIL3112 based card of course, is you need a different EEPROM. Now, there are two different ROMs you can use on these cards, but the one that I'll be using in this video is ripped from a Seritech 1S2, I believe is what it's called, SATA controller card that was developed and released specifically for PowerPC Macs. But the controller on them is identical to this, and the layout of the board obviously is pretty much the same as well. Of course it has to be. Now, with this particular card there is one difference which I'll point out later, and you have to change this on the card in order for it to work after flashing it for Mac, but like I said, I'll go over that later. But the first thing you're going to need is a new EEPROM to put on the card, regardless of which ROM you use. However, for the ROM that I'm going to use, the Seritech ROM, one of two specific EEPROMs are required. And the one I'm going to be using here is this EEPROM. It is a PMC PM39LV040 ROM, and of course this is a 512K EEPROM. And now, regardless of which ROM you use, you need a 512K EEPROM, but for this ROM you either have to use this PMC chip, or you can use an MX29LV040 chip instead of this one. But it has to be either this PMC chip or the MX29LV040 for the Seritech ROM to function. With that out of the way, the first thing we need to do is we need to put this chip in an EEPROM programmer before we even solder it onto the board, of course, and we need to program it with the ROM from the Seritech card. So I'm going to go ahead and get this EEPROM put in my EEPROM programmer here, and then we'll begin the process of flashing it. Alright, so as you can see here, I've got the chip installed in my EEPROM programmer here, and I actually do have it cattywampus in this PLCC32 socket intentionally, and that is because this particular socket, I guess, I don't know if this is an issue with all PLCC32 sockets or just this particular one, just has trouble connecting to the pins for some reason. So I found if you kind of put it in there like cattywampus, like kind of at an angle like this, it actually works better for some reason. But the first thing we need to do over in the EEPROM programming software here is we need to select the model chip you have installed. So in this case, I've already selected PM39LV040 because that, of course, is the chip we have in there. But if you use the MX chip or any other 512K chip for the non-Seritech ROM, and by the way, I will put a link to both ROMs in the video description, so you can use whichever one you decide to. Just keep in mind, only the Seritech ROM will work in classic macOS, so OS 9 and older. So that's why I'm going to be using it in this particular video and on this particular card. So with that, the first thing you want to do is just select the model of the chip, and then you want to check the ID to make sure it's actually detecting the chip properly. So go ahead and select Read ID, and as you can see, it did detect the ID correctly, and that indicates that all the pins are making proper contact in the socket. So with that done, since this is a new EEPROM, of course, we don't really have to dump any original firmware off of it. So what I'm going to go ahead and do now is just load up the Sarytech firmware here. So you can see this is named 1S2 indicating that it is from a Sarytech 1S2 card and only works on a 512K EEPROM. So go ahead and select that and load it in here. And you can see all the contents have been loaded. You can see that this is indeed an F-code based ROM image here. So now we'll just go ahead and select Program. And as you can see, it's still not making proper contact, so we're just going to cancel that. And I'm going to move it around a little bit in the socket. Found if you kind of pull it up as much as possible, it makes better contact. So now, with that adjusted, let's try to program it again. And as you can see, that time it worked just fine. Alright, so as you can see, the EEPROM was flashed and verified successfully. So now, in the case of most cards, all you need to do is desolder the original EEPROM from the card, and then solder this newly flashed EEPROM on, and it should just straight up work after that. But like I said, with this particular card, there is one extra step required, which I will show you. So for now, I'm going to go ahead and get my camera in the tripod here, and we'll just begin the process of soldering this EEPROM onto the card. Alright, so as you can see here, I've gotten the card here up on my board preheater, so we're now ready to begin the process of desoldering and replacing this EEPROM. Now you don't have to use a board preheater for this, but you will definitely need to use hot air. So with that, I'm going to go ahead and turn on the board preheater, get the board up to temperature, and then we'll apply some flux and remove the chip. Alright, so the first thing we need to do, of course, is apply some flux. Just like so. And then once my hot air gets up to temperature here, I'm going to go ahead and remove the chip. Now I always like to use no nozzle for these larger chips like this, just because it makes it heat the chip more evenly. So go ahead and let it desolder here. And as you can see there, the chip has now been removed. Now before we solder the new chip on, I always like to go over the pads with some fresh solder just to make sure the new chip fully solders in position. So go ahead and turn on my soldering iron here, and we'll just apply a little bit of new solder to the pads. Alright, so the fresh solder has been applied, so now we'll just go ahead and take our new EEPROM, of course our PMC EEPROM as you can see here, place it onto the board, and then heat it to fully solder it in position. Alright, so that's pretty well aligned, so we'll just go ahead and heat it up. Okay, so that looks pretty good there. So now we'll just let the board cool down. And for this particular board, once it cools down, I'll go ahead and show you exactly what the second modification is that needs to be made. But if yours just works just fine, most cards will just work fine if you go ahead and put them in right now that the newly flashed chip has been installed. But if it does not work, so if it doesn't show up properly in open firmware or does not show up properly in the Mac OS at all, then you will probably have to do this modification as well. So I'll go ahead and let everything cool down and show you exactly what needs to be done. Alright, so as you can see here, I've got the datasheet open for the SIL3112 SATA controller right here, and the configuration option in question that needs to be modified on some cards, including this particular one, is this option right here, and that would be IDE_CFG right here. As you can see here, it says that it's kind of weird because it shares this pin with address line 0 of that ROM we just installed, but it also has the function of being pulled either high or low, setting the IDE CFG option in the chipset itself. So as you can see here, it says a high on this pin sets mass storage class, a low sets RAID mode. Now RAID mode is the problem here. So the Saratech ROM as well as the other ROM do not work when this card or when this controller is set into RAID mode. So you can see that the configuration of this is internally pulled high. So in theory, all we need to do to disable this option is just remove any particular strapping resistor that may be on the board. So if we go head over to the board here, you can see I've got it right here. We want to look for the pin on the SIL3112 where, or that may connect to, or that does connect to the pin 42 on the chipset here. So you can see that was the pin number here on the data sheet. And if we go over and look at the actual pinout of the chip here, you can see that pin 42, or 40, whatever pin it was, let's see, pin 42, yeah. Pin 42 is located right here. So you can see it is labeled IDE CFG as well as address line 0 for the flash chip. You can see pin 1 is located right there. So we just have to go over to the chip here, or the board, look for pin 1, which you can see is right there. So we'll go ahead and flip it around so it's in the correct orientation to make it easier to see. So now we have pin 1 right here, and so pin 42 should be 6 pins up from this side right here. So let's go ahead and zoom into that here. And the best way to really figure this out, if this pin is being pulled low, is just check resistance from that pin to ground. Now I can't really do it with just one hand here holding the camera, but I did check that earlier, and it read about 600 some ohms to ground. So obviously that pin is being pulled low, so we just have to figure out what is pulling it low. So if we take a look here, let's see if I can get the camera a little more stable for you here. So if we take a look here, if we go pin 6 pins up from the bottom, so 1, 2, 3, 4, 5, 6, you can see it connects to this trace right here. And if we follow that trace over here, you can see that it goes through this resistor pad. Not sure what that's for. It goes down here into this resistor, which is a 0 ohm resistor, which connects to another trace, which is even harder to see here. You can see that one connects to another trace, which goes up here, connects to this pad of this resistor, which then goes to ground right here. And I did verify that, checking continuity. So we either need to remove this resistor or this 0 ohm resistor, because that's in line with it as well. Again, not sure really why they did it this way, but I did measure this particular resistor here, and it measures that 600 some ohms that I was seeing from that pin to ground. So obviously that is our pull down resistor there. So with that, I'm going to go ahead and get this board back on the preheater, and we'll go ahead and probably just remove this 0 ohm resistor right there. So I'll go ahead and do that now. Alright, so as you can see here, I've gotten the board on the preheater once again. So again, that resistor in question that I just showed you before is this resistor right here, this 0 ohm resistor. Of course, we could also remove this one, but I think the 0 ohm would be the best one to remove here, just because it's easy to replace if necessary. So now we'll just go ahead and just apply a little bit of flux to it, just like so, and then we'll just simply heat it and remove it. Alright, and simple as that, the resistor has now been removed. So I'm going to go ahead and let everything cool down. We'll install this card into a PowerPC Macintosh and give it a test. Alright, so as you can see here, I've gotten the card installed into my PowerMac G4 here. So now I'll just go ahead and turn it on. Now the first thing I'm going to do is just boot into Open Firmware, and I'll show you how to run a quick check to make sure that the card is detected and to make sure that the EEPROM or the custom flashed ROM is actually loaded and running properly, or whether or not the card itself is not detected at all. So I'll go ahead and power it up and boot into Open Firmware. So I've got the keys held down here. Alright, and as you can see here, we are now in Open Firmware. So all you want to do here is just enter dev //ls and press enter. And that'll just list all the devices that are in the system currently. And you want to go down and find the PCIe section here, and you can see that it detects that PCI bridge there, which is that PLX chip on the board. You can see it detects the USB. It actually detects it as 2 USB controllers, which is interesting. You can see it detects the FireWire also as 2 controllers. And the Seritech 1S2 at A. So of course, if it says Seritech there, that means the firmware has loaded and is working properly. However, if it shows a device ID of, I believe, 1095-3112, that means that the card itself is detected, but the ROM has not loaded. So with that, I'm going to go ahead and let the machine finish booting by just typing mag boot. And we'll take a look at the card in OS X. Alright, so as you can see here, the machine has booted up. So let's go ahead into About This Mac. We'll go to PCI cards. And as you can see, it is indeed detected. You can see right there, Seritech 1S2. And everything seems to be loaded properly. You can also see it detects the PCI bridge, the PLX chip, as well as the USB and FireWire controllers. So that is awesome. Everything looks like it's working as intended. So now I'm going to go ahead and shut the machine down, connect a drive to it, and we'll also check it in OS 9 to make sure it works in there as well. So I'm going to go ahead and get a SATA drive connected to this card and make sure that works. Alright, so as you can see here, I've gotten a SATA drive connected. I've actually connected an mSATA drive with a little adapter here, and I couldn't find a Molex to SATA power adapter, so I just used a secondary power supply there to power the drive. So a little janky, but it sure works. So as you can see here, the drive is showing in the operating system here. Funnily enough, though, it doesn't show anywhere in System Profiler, at least that I can find. It's not in SCSI, it's not in PCI cards, it's not in ATA, and it's not in serial ATA, so that's kind of funny. But it does show up in Disk Utility, and of course, I was able to partition it, as you can see here. I did install OS 9 drivers because I do want to put my copy of OS 9 on there and see if it can boot from that successfully. So I will try that in this video. But yeah, it does detect, it does work. There's the mSATA SSD right there working as intended. So let's go ahead and close this, and I'm just going to go ahead and copy my OS 9 system folder and stuff like that onto the drive. So as you can see, it is working, it is copying all the data. So I'm going to go ahead and get everything copied over for OS 9, and we'll go ahead and see if it can actually boot from it. Alright, so I've gotten everything copied over, all the OS 9 stuff. As you can see, I unplugged the IDE hard drive in here, so now this mSATA SSD is the only drive connected. And of course, I've also blessed the system folder from within OS 9 beforehand. So now we'll go ahead and boot it up and see if it boots off this drive. Let's see if it detects it. Oh, looks like it has. And it's booting OS 9, and wow, it's booting quickly too. Alright, so OS 9 has booted off the SATA card. As you can see, the mSATA SSD is detected. So let's go ahead into System Profiler and see what it has to say. So yeah, as you can see here, it actually detects it on the SCSI bus in OS 9, which is quite interesting. See mSATA right there. And you can see the mSATA SSD detected and working. So that is how to fully flash an SIL3112 SATA controller card for use in a PowerPC Macintosh. Hope you enjoyed this video.